We're going to start on page 347 in the book. And today we're going to go over parts of the parabola. And really what you have to get out of this is just what the parts are. And we're going to use a sort of, and maybe a little bit silly, but an example of a human cannonball. So Rosa is this human cannonball, and she gets shot out of this cannon, as you can see. You're given the equation right here. And that's an equation that you should know a lot about. Before we get into the details of Rosa and her cannonballness, you can tell that this is a parabola because it has one letter squared, or x squared specifically, so we know it's a parabola. And you also know that it opens down because it starts with a negative. So what we're going to do today is sort of start with what you should be most familiar with and build from there. Because we're going to define parabolas a little bit differently than you've done in the past. We're going to think of a parabola as a conic section and not maybe as just as a quadratic equation like you're used to. All right, so let's take a look at the rest of Rosa. So Rosa is going to have her launch filmed, and there's going to be two cameras. So we already know, and I'm going to come over here to the right, we already know Rosa's path is a parabola that opens down. So we already know that it looks like this. You know some things about this parabola, right? Her maximum, her highest point is called the vertex, also the maximum. And so when she's being filmed, she's going to have two cameras. Camera one's going to be stationary, and it's going to be directly underneath the vertex. So camera one is right here and is not moving. Camera two is going to be positioned on a cable above her. So camera two is allowed to slide. So camera two is going to slide back and forth on this cable above her, obviously high enough so that she won't hit it. They give you the positioning of these cameras, or at least camera one. So camera one is going to be 58.25 feet high and horizontally 82.143 feet from her launching point over here. Let's say that's over there to the left. So I don't know why, but they switched the vertex to point P, and they're asking us to find the points of the vertex. And so this can be easily done since we know the x value of the vertex, since the vertex and the camera one are directly underneath each other. You can just simply take that x value and plug it into the equation. So it would be negative 0.0112, and then of course 82.143 squared plus 1.84 times, again, that same number, 82.143, and then, of course, plus 5. And this gives you 80.571. So the coordinates of the vertex are 82.143, and then, of course, the y value we just calculated, 80.571. So don't forget about the simplest thing. You can just simply plug numbers in to generate, obviously, the y values. So when Rosa is at point P, how high must the cable be secured so the cameras are the same distance apart? The cameras are going to be the same distance apart the entire path, but right here, we want to make sure that this space and this space are the same. This is an important part of a parabola when looking at it as a conic section. So if we take that y value that we just calculated, 80.571, and obviously we're going to subtract how high it is, 58.250. That gives you right around 22.321. And then we're going to add that back to that 80 number because we want to go higher. And so this value is another important value. This is 102.892 feet. Now you should also be able to write the equation of this line. You can see that it's horizontal, and if we were to kind of think about an xy axis maybe being superimposed on here, so if we think about this as the y-axis, then this is obviously a horizontal line, touches the y-axis at 102.89. Being able to write the equation of a line, either horizontally or vertically, actually both, is something that we're going to do a lot of with this. So we have y equals 102.89. So if we think about just graphing these points, just putting it really on a graph and just taking a better look at it. So here we have the line, which is the cable that camera 2 is on, which is a little wobbly, sorry. We have camera 1, if we go over about 80 and up about 58 here, 60. This is where camera 1 is positioned. And then, of course, the vertex is up directly above there, right about 80. And without plotting any points, of course, we can just sort of draw in Rosa's path. All of these things are representational of a real part of a parabola. Of course, Rosa's path, I should say, her path, not her person, because she's a person. Her path is the parabola. Camera 1, we're going to call that the focus. That's what we're going to call it from now on. But if it helps you to sort of picture this example, that's the idea, is that you have a real-life example to sort of think about if you get confused. The cable that camera 2 is on is actually called the directrix. And this is an important relationship because these two spaces are the same. So the space between the vertex and the directrix and the focus, the directrix and the parabola and the focus and the parabola, these two spaces should be the same. So as this moves up and down, imagine the camera is allowed to move here and this one doesn't move. And so like this distance and this distance are the same. They're not the same throughout the parabola, but any one point is equidistant. This is how a parabola is formed, and this is the definition of a parabola. All right. Sorry, I lost page 2. Here we go. And so I'm going to skip right down to here. And so right above number 8, the definition of a parabola, and this is something you'll have to know. Parabola is a locus of points. Locus, a fancy way of saying set. So it's the set of all points in a plane that are equidistant from a fixed point and a fixed line. And so that's what creates a parabola. It's a line and a point. So we have a circle, which is, I'm going to go off here a little bit. A circle is created by one point and one distance, and all of the set of all of those points create a circle. And a parabola is created from a line and a point. And if we think about all the points equidistant from both of those two things, then that's how you form a parabola. Now, there's some other parts of a parabola that you obviously are aware of, the vertex, and of course, this axis of symmetry, which I'm going to sort of draw a different parabola because I don't like that one because you can't see it very well. So if we think about a parabola, oops, lost my pen. So if we think about a parabola, I'm going to move it over a little bit. So here's our parabola. This is the vertex. In this case, it's a minimum. The focus always lies inside the parabola, directly in line with the vertex. And then the directrix always lies outside the parabola. And basically, the directrix sort of directs the parabola away from it. Then you have this axis of symmetry that actually touches all three things. It touches the focus, the vertex, and the directrix. And the axis of symmetry is always perpendicular to the directrix. Now you have a formula sheet, and you should look at it. All right, don't try to do this without the formula sheet, because we're going to change what we think of as the equation of a parabola. Right now, and I'm just not even reading these questions, I'm just using this space. Right now, you think of a quadratic equation, y equals ax squared plus bx plus c. You may even think it as maybe just y equals x squared plus 5, something like that. But we're going to not have those types of equations. We're going to talk about this parabola in terms of that space between the vertex and the focus and the vertex and the directrix, and that space is d. And so our equation is now going to be y equals 1 over 4d times x squared. If it's a left and right facing or open parabola, of course, then that means we have x equals 1 over 4d, and this now would be y squared. And so this value of d is super important and one that we're going to use a lot. D is the distance, and I'm using an absolute value because it is a distance, so it's always positive, from the focus to the directrix. It's also the distance from the directrix to the vertex. So please do not use D for directrix. Don't come up with your own symbol. because that is already taken. D is in your equation, and D is something we're going to use. So just to kind of give you a little example here of how you'll see this used. Let's say we have a parabola, and this is not this example or anything else, just a made-up example here. And it opens down, and the vertex is at 2, 5. Focus is at 2, 3. We want to find the directrix and the axis of symmetry. And this is really kind of hard to just imagine, so you want to actually plot some points, and you maybe count the squares or come up with some relationship. A lot of times with conic sections, we will use the graph, not necessarily to draw the graph always, but just to sort of develop or establish the relationship between things, so you can kind of figure it out backwards. So we know the vertex is 2, 5. I'm going to label that so I don't forget that that's the vertex. The focus is at 2, 3. So we know that it opens down. We don't really know what that looks like. But that space right there, that is D. That space between the vertex and the focus. So we want to do that same space, those 2 points, and go the other way. And this is where the directrix would be, up here. That, of course, is a line. And to write the equation of the line, don't just say the directrix is 7 or 2 or 5 or whatever. Don't just give it a number. It's going to it touches the y-axis at 7. So it's y equals 7. Now the axis of symmetry, of course, is the one that runs right through here and touches all 3. And so the axis of symmetry touches the x-axis, in this case, not always, just in this case. And so the axis of symmetry is x equals 2. And that's how you write the equations for both. All right, now we're going to talk a little bit about inverses. And this is something that you should remember. And if you don't, we're going to go over it right now. An inverse is when you switch the x and y. And the symbol for it is this. And we've done inverses with lots of things. And it's when you graph an inverse, it's as simple as switching the value. So if we think about the parent function, which I know we haven't done in a while, but it's 0, 0. 1, 1, negative 1, 1, 2, 4, and negative 2, 4. So this is our parent function right here of y equals x squared. To graph the inverse or to find the inverse, you could switch the x and y and solve for y. But on a graph, it's really much easier than that. All you have to do is switch the values. So if we think about switching the values, we would have 0, 0, 1, 1, of course, 1, negative 1, 2, 4. Oh, sorry, 4, 2, didn't switch them, and then 4, negative 2. And then the inverse, of course, is this way. So we're going to have some left and right opening parabolas. We'll get into the details about how to figure those out and how to do them another day, but just be aware of the fact that that's what's going to happen. So if we try to find this inverse, I just want to go through, sort of help you kind of remember one. So let's do A. It says for each parabola, write the inverse and then sketch the original parabola and the inverse. You can use your calculator, of course, to draw any graph, as long as you can solve for y. So let's do the inverse first. So we're going to switch the x and y. X equals y squared plus 2. Of course, now we want to get this thing where y is by itself. X minus 2 equals y squared. Now, an important part of this is when you take the square root, of course, you get 2 values. And so if you were to put that in the calculator, you would have to put it in for 2 things. You'd have to put it in y sub 1 equals the square root of x minus 2, and you'd have to do the second, or the y sub 2, and that would be equal to the negative square root of x minus 2, if you wanted the entire parabola. But of course, since we're going to graph them both, it's easier than that. And we know this is a parabola that just is up 2, so there's our parent function just moved up 2. Use the calculator if you don't know the points. But then to graph the inverse, since we graphed the original, all we have to do is switch the x and y. So we would go over 2, and then from there we go over 3 up 1, over 3 down 1. So to graph the inverse, we could just take the original and switch the values. This is not really something that you have to do. It's not in your assignment, but it is something that we will see it on the end of the year test. And I just wanted to take an opportunity to help you remember some of these things before it's too late and you forget. Now, you do have an assignment, and your assignment's on page, not this page, because there's nothing there. It's on page 352. Page 352, and it is 28, 29, 31, and 32. Thank you.